Section 7.1 is our very first section where we get to do decimals. Can I get a yay? Yay, woo, yay, decimals. All right. In particular, this section we're going to talk about finite decimals, and we'll talk a little bit about what we mean by that as we get going. But let me take a look with you first at just a little bit of language. The first piece of language is actually the word decimal. The word decimal comes from the Latin word meaning 10, and that has to do with the fact that we work in our number system in base 10, right? We have 10 numerals, 0 to 9. 10 is not one of our numerals. That's two numbers together. You're the 1 and the 0. So 0 to 9, we have 10 numerals. And in terms of language, just as a reminder, we're going to take a look at what we call our certain place values in our decimal-based system. So the first thing you could do is you can write down, how many do I have of them? 1, 2, 3, 8. 8 lines. So 2 lines in a decimal point and then 6 more. And we're going to give a name to each one of these locations in our decimal-based system. And we'll just start on the left and move our way to the right. So this first place value right here on the left, what do we call this? Yes, we call that the tens place. There's a couple of names for the next place. What do you think you might call the next place? Ones or units. Very good. So sometimes we call it the ones place. You'll hear it also called the units place. So you can write either of those down there. All right, so after the decimal point, moving one over, what is that location called? That is the tenths place. That TH on the end makes a big difference, so make sure it's included. What's after the tenths place? Hundredths. After hundredths. Good. Thousandths. After thousandths? Oh, some of you are trying to get ahead of me. 10,000ths first. 10,000ths. Sorry, I'm trying to exaggerate how I'm saying it so you hear all the letters in there. What's the next one? Not yet, Andrew. 100,000ths. And Andrew really wants that millionths place. He's excited. All right, this one is actually 100,000ths first. All right, Andrew, what's the next one? I have no idea. Man. Yeah, the last one here that I have on here would be millionths. And could we keep going? Sure, we could definitely keep going. There's nothing wrong with continuing on. We would have 10 millionths and then 100 millionths, and then we'd have billions. Yeah, we would keep going. Yeah, okay. So this is just to give us a little bit of an idea. What we're going to do next is we're going to take some numbers and some language, and we're going to convert them back and forth, okay? So the way you probably read this word is something like this: 32 and 32.4236. Who reads it like that? That's how I read it. What you will hear some children read is you'll hear them read that point as a dot. Does anybody read it as a dot? Thank you to the internet, right? Dot things, right? So we'll hear dots. But if you were writing this, not that this is a great example because there's 4 decimal places or 4 places after the decimal point, but if you were writing this on a check, you wouldn't use the word point or the word dot. You'd actually write it out with some proper language. So we're going to work with that proper language. The first part is pretty okay. We tend to do that correctly even when we speak. What do you do when you do that value before the decimal point? What is that number? That one's 32. There is a hyphen between the 30 and the 2. So when we combine 30, 40, 50, that kind of stuff with the numbers after it, we do put a hyphen between them. All right, so I think a couple of you already mentioned this, and I think I even said it inadvertently. When we see the decimal point, what's the word we do use? We use and. All right, the next thing we're going to do is we're going to write down this number as though it were just a plain old number without any decimal points surrounding it at all. So when I see 4236, what do I write down for 4236? Excellent. Oops, I didn't mean to do it in blue. Let's go back to my black. 4,000 200 What else do we have? There it is, yeah. 30, and then there's that hyphen, 6. Notice the only hyphen's actually between the 30 and the 6 right now.
I'm going to
Yeah.
ask, like, so there's no commas or anything else?
There aren't any commas in there at all. Mm-mm. If you put some in there, I'm not going to freak out about it or anything. I actually had a colleague once who would count off if you did. So it was very, very rigid. I'm not terribly concerned. I'm more concerned that you say it right in front of a classroom than that you write it down in the exact precision. I will tell you this. I often have people spell the number 40 wrong. Do you guys know how to spell the number 40? It's a really common mistake. Yeah, F-O-R-T-Y. Any idea what people often will misspell it as? Yeah, we use a U in the middle there. Yeah, it's not a big deal if you do that. I mean, I'll mark it and I'll tell you it's incorrect, but I won't take any points off. So, yeah. I've had colleagues who take off for spelling as well in math. Isn't that fun? So thank you, Dr. Hands, right? Okay, just checking. All right, we're not done, though. This is the 4,236. Right, we need to talk about which place value it's in, and we need to look at the last place. So wherever we end the value, in this case it's that 6 that I just highlighted over. I'll make it look a little bit better. That right there, that is the 10,000th place, right? You can just count over. We've got tens, tenths, hundredths, thousands, and then 10,000. So the last thing we're going to write down is the word or the phrase 10 thousandths. And there is a hyphen between the 10 and the thousandths. And of course, you need to make sure you've got that TH there on the end of thousandths. Is that okay? Okay, we're going to go the other direction, I believe, next. We have the word 536 and 76 thousandths as our, not word, the phrase. And we're going to write down the numeral that looks like that. So how will this look? Like, tell me the numbers I write down, not with any other language, just the actual numbers.
536.
Okay, and then a decimal point, right? 076. Ooh, good. 076. Now, where in the world did that 0 come from? Because it was not written in there, right? Yeah, I have to make sure that I end in the thousandths place, which is the third decimal over. So 76 needs to occur in the last 2 locations for it to actually be in the right place on that. Okay, everybody good with that? Awesome. Okay, along with this lines, we're going to do the same kind of thing we just did a minute ago. Go ahead and write out some of those lines. I'm going to have you just write 3 on either side of the decimal point to show you what I want to show you about this particular one. So 3 lines, decimal point, 3 more lines. We're not going to write down the words, though, on this one. What we're going to do is we're going to write down the place value in terms of the value of that place. For instance, what is the first location? It's hundreds, right? The first one on the left, that's the hundreds place. I just want you to write down underneath it 100. And then we're going to talk about these after we do. What's the next one? Tens place, so it's a 10. What's the next one? 1. How about after that? Yeah, it's 1/10. I'm going to write it as a fraction, and I'll explain why again in a second. What is the next place? Hundredths, so it's 1 over 100. And the next one? Thousands, so it's 1 over 1,000. Very good. This is actually base 10 expanded form. What your book will do, this is my note at the bottom, is that it will use negative exponents. In other words, when you see the 1 over 10 here, it's going to write this as 10 to the negative 1. It's going to write this as 10 to the negative 2. And it's going to write this as 10 to the negative 3. So if you're checking your work, just be aware that that's what it's going to do. I don't want you to do that. The reason I don't want you to do that is because all of a sudden, when I write those negative exponents, you lose some of the concept of what's going on. Right? I mean, you do. 10 to the negative 1 all of a sudden looks like a number that's got a negative exponent, which is a little strange. And it looks kind of large because it's got a base of 10 when it's really not a large number. It's a small number. And so you lose part of the concept of what's happening. So as we do our problems, I'm going to do an example here for you. We're going to use the 1 over 10, the 1 over 100, the 1 over 1,000 as the notation that we're going to be processing. Okay? Another thing that's helpful to keep in mind as you're working through this, and many of you will be teaching at ages where you're going to be working with decimal places, you're going to be working with money. Right? Money happens first grade, second grade, and even on a little up from there, is that when you're talking about this decimal of the 1 over 10th, you can talk about what coin? A dime. This is a dime, right? Because it's 10 dimes make a dollar, right? And when you're talking about the second decimal place over, you're talking about pennies, right? This one's pennies because there's 100 pennies that make a dollar. So you can use that kind of language as well, and it works really nicely because a penny is 1/100th of a dollar, and a dime is 1/10 of a dollar, and so forth. All right, so let me show you what we're going to do with the base 10 expanded form that this is referring to. All right, we have the number 103 and 300ths, right? Okay, so we're going to write this in expanded form. So what does that look like? Well, it looks like each numeral that I have times its place value. 1 times 100 plus, and we're gonna go ahead and write in the zeros just for completeness. 0 tens plus 3 ones plus 0 1/10ths plus 3 100ths. And this is what expanded form looks like. And if you think about this one in terms of money, it's really nice to talk about. Because this says I have 1 $100 bill, 0 $10 bills, 3 $1 bills, 0 dimes, and 3 pennies. And you can see that by the place value that's right next to it in terms of those locations, which is kind of nice. All right, let me show you another useful visual, is what it really is, with decimals. And this is called a decimal square grid. So this is a 10 by 10 grid containing 100 squares. So make yourself a square in that space that you have. And then I want you to take your square and I want you to divide it into 10 rows and 10 columns. And mine will be as best I can do with the technology I have. Yours will look better because you have the ability to draw a little bit better than I do actually on my screen. Okay, those are by no means perfectly even. They should be. If I drew it well, they would be, but I didn't. So, and we're going to do the rows the same way. Oh, it got worse at the bottom, didn't it? Oh my goodness. Okay, so imagine. You guys have got good imagination. Imagine it looks good, because it doesn't. All right, so this is just a 10 by 10 square grid. All right, so you're going to get an opportunity to draw it again. If you flip your page, we're going to draw this image for the number 0.24. What is that? How should I say that? 24 hundredths. So what do you think we're going to do with this decimal grid for the number 24 hundredths? We need, say it again, what you have said. All right, so we're going to need 24 boxes filled in, right? And while you could fill them in at random, that would be unhelpful to me and probably unhelpful to your students. So doing it in such a way that you either do 2 columns and 4 extra boxes or 2 rows and 4 extra boxes is probably your best bet on this. So I will take my very inaccurate but drawn grid and I'll move it over here to the next page. And I'm going to shade in 24 of the boxes. So here's 10, here's 20, and I think that was too many. And here's 4 more. So 24 of my boxes are shaded in. This image also works, give me just a second, this image also works really well if you talk money, right? Because we could actually talk about taking 100 pennies and then taking that image of having only 24 of them present. Yes, Erica?
Do you suggest going across the top first, or?
It doesn't make any difference whatsoever. So you can do it across the top or you can do it down the columns either way. Okay, any questions on that one? Okay. Let me throw in another question for you right here. Why do you think it's a 10 by 10 grid? Like it is, and we should use that. Why, though? It's got 100 boxes, but why are there 100 boxes? And why are we doing our grid like this? Because we work in base 10, right? What do you think it would look like if we were working in, say, base 5? It would be a 5 by 5 grid, and we would have how many boxes? 25. So the fact that we're having this 100 grid, or 100 block grid, is because we're working inside of base 10. They are going to give you some examples, I believe, in your homework or group work that's going to talk a little bit about what happens when the grid looks a little bit different. I believe that's going to happen. I totally might be making that up now. That might be in my other class. But if it is, that's exactly why it's happening, though, is because it's a base 10. Okay? All right. Theorem 7.1. Theorem 7.1 talks about taking fractions and turning them into decimals. In particular, it tells us that if we have a rational number, a over b, in simplest form, what does simplest form mean? Yeah, the greatest common factor between the numerator and the denominator is 1. It means it's completely been reduced. Okay, this is the most common problem students have with this particular theorem is they forget to reduce the fraction. Okay, so you have to reduce the fraction to make this work. If we have a simplest form fraction, it can be written as a terminating decimal. Terminating means the decimal stops. It doesn't keep going. Okay? It can be written as a stopping decimal, a terminating decimal, if and only if, when we factor the denominator has factors that are 2's, 5's, or 2's and 5's. Nothing else. There's no 3's in the factoring of the denominator, no 7's, no 13's, none of that. Any of that happens in the denominator on a reduced fraction, then the fraction is not a terminating decimal. That's what this theorem says. So we're going to do a couple of examples where we've got fractions, and our goal is to determine if, in fact, they are a terminating decimal. But we want to make that determination before we go through the process of figuring out what the decimal is, okay? Which means we're going to be using that theorem. So 9 over 24, what is the first thing you notice about that fraction? It's not reduced. What do the numerator and denominator have in common? 3. So our very first step to do is to reduce them by dividing the numerator and the denominator by their common factor of 3. 9 divided by 3 is 3, and 24 divided by 3 is 8. Okay, so that's step 1. We now have a reduced fraction. Step 2 is to take that denominator and to factor it. So 8. How will 8 factor? 2 and 4, and then 4 is 2 and 2. So any which way you do it, you end up with 3 2's. Let's go back over here. It says the denominator contains only 2's and 5's. Does it contain only 2's and 5's?
Yes.
Yes. And this word and is not meant to confuse you. It just means that it has the possibility of being one or the other. So the fact that this one has only 2's is totally cool. There's nothing wrong with that. All right, so what does this tell you about the fraction 9 over 24? It can be written as a terminating decimal. Very good. So this is a terminating, or it can be written as a terminating decimal. In decimal form, it will terminate. So since that's the case, it says, if so, that is, if it's a terminating decimal, we're going to write it as a terminating decimal. That means I want to figure out what is the decimal expansion. And I know your calculator can do this, but that's really not you. That's your calculator. So when you're turning these into terminating decimals, I'm going to expect to see the division, because that's what your students would be doing when you're teaching them this, right? So we're going to actually show it. Remember, the numerator is what goes underneath the division sign. That's my 9. And then the denominator is what goes on the outside of the division sign. That's the 24. And you can do this, but you're also welcome to use your reduced fraction instead, which is probably going to be easier, and do 3 divided by 8. So are we good with everybody using the reduced one? Is that okay? All right. So let's go over here and divide 3 by 8. So obviously we need the decimal point in the 0 because it doesn't go in at all. And then the decimal point comes to the top right here. This is a little bit of an unfortunate ordering of things because I haven't told you how to divide with decimals exactly yet, but just pretend for the moment, okay? It doesn't come until later in this chapter. All right, let's look at the 8 and the 30. How many times does 8 go into 30? 3 times. Okay, and then what is 3 times 8? 24, excellent. And I'm going to subtract 30 minus 24. is 6, and then I'm going to need another 0 to bring down, right? All right, now how many times does 8 go into 60? Is it 7? Okay, good. And 7 times 8 is? 56. Excellent. You guys are remembering a good amount of multiplication today. That's awesome. How about 60 minus 56? 4. All right, and then we're going to do the 0 one more time to bring it down. Oops, I drew that one a little too far. And I didn't draw that one at all. Okay. There's my next, oops. I tell you what, I'm losing my mind. All right, here's my next 0. Fabulous. All right, so what in the world do I get when I do 8? How many times does 8 go into 40? 5. And what's 8 times 40? I mean, 8 times 5? 40. Here's my 40. All right, I'm done when I have a remainder of 0. Okay? If it feels like it's continuing to move along, like you got 5, 6, 7 decimals, that's okay. It will eventually stop unless you've made an error before that. This has to terminate. You already said it. You already did it. So you know it will. Just continue to divide until it actually goes away. All right? And you're welcome to check to make sure that you're getting the 375 correctly using a calculator. Use your calculator to check. That's perfectly fine. Okay? But the work itself needs to be shown. So the decimal is 375 what? Thousandths. Very good. 375 thousandths. 10 and 24. What do we notice? It's not reduced. So what do we have to do? Reduce. And we can divide them both by 2. Fabulous. So 10 divided by 2 is? Good. And 24 divided by 2? 12. All right. Step number 1 done. 5 over 12 is reduced. Step number 2 is to do what? Factor 12. Fabulous. So how does 12 factor? Okay, 6 and 2. And then 6 will be 3 and 2. So my factors are 3, 2, and 2. So is this one a terminating decimal? No. What's the problem? Yeah, that 3. This is not terminating. Now, pause for a moment and consider with me, if you forget to do this reducing step, what's going to happen here. So that is, if I failed to do the 3 over 8, I failed to do the 5 over 12, and I just looked at the original denominator, they both have a 24 here, right? So if I factored 24, what would happen? I'd get a 3, and I'd get some 2's, right? A bunch of 2's, and I'd get a 3. So I would actually have a 3, and because I would have a 3, the property would say that I wouldn't have a terminating decimal, right? I mean, that's what it would say. And the problem is that would be true for part B, right? It actually gave me the right answer, quote unquote. But on part A, it would have given me the wrong answer, right? And the reason is because, if you'll notice what happened, that 3 divided out on the first problem, didn't it? That was exactly the problem, exactly the reducing step that we skipped. So you really do have to check the reducing step before you move on, or you might end up with an answer that's not appropriate. Okay? All right, next thing we're going to do is we're going to consider comparing or ordering decimals. All right, so as we look at these, we're going to line them up by place value. We're going to read the numbers from left to right and find the first place where they are different. And then the third thing is we're going to compare the different digits. So as we compare them from left to right, which one's smaller, which one's bigger, between the first one and the second one and the third one, and so forth. All right, so the first one that we're going to look at of this variety has these numbers. We have 13 and 4,919 10,000ths. Very good. I have 13 and 492 thousandths. 13 and 49,183 10,000ths. And the last one is 13 and 49,199 10,000ths. Okay? That was my mental exercise for the day. Did it work for you too? Mental processes are going. Fabulous. Okay, we need to line these up vertically. Okay, it's so much easier to compare these if they're compared on top of each other. So you are going to go ahead and write these down. You've got some space there to do it, and just write them down one on top of the other. Sometimes I have students that actually like to draw lines between them because it helps them to keep them straight better. So whatever it takes for you, if you can do it like I am where I'm not drawing lines, or if you need to draw or want to draw lines, totally cool. Something else that sometimes I will have students do is that they will make them all the same length. So if I wanted them all to have 5 decimal places at the end here, what would I have to do with these 3 locations? I would put a 0 in them, and that would also be appropriate. Sometimes it helps us to think about them when they're the same number of decimal places. So if that helps you, put some zeros in there, okay? All right, so as we take a look, we're just going to go one place value at a time. The tens place, they match, right? The ones place, they match. The tenths place also matches. Hundredths place matches. But then when I get to the thousandths place, I notice that something's different. Which one's different? The second one. Now the second one's different because it has a 2 in it instead of a 1. So what does that tell me about the second value? It's the biggest because it has the biggest value in that location. Okay? So this right here is my largest value. And now, as I continue to work, I'm ignoring it because I already know that going from smallest to largest, it's it. It's the largest. I don't have to consider it anymore. And if it helps you, you could actually give it a number. This will be my 4th number. And when I write these out, this is going to be the 4th one that I use. And now, in my mind, I'm sort of going to ignore that value. I'm not going to consider it anymore. If it helps you, draw a line through it so that you're not thinking about it anymore. That will work too. Okay? All right, let's move on to the next place value. So we've already done this one. The next one in the, what are we at? 10 thousandths, right? I've got a 9, I've got an 8, and I've got a 9. One of them's different, and it's the smallest, right? Because that 8 is smaller than the other 2 9s. So what does that tell me about this number in the 3rd location compared to everything else? It is the smallest. And again, if you want to give it a number, it's going to be the first number in my list of numbers because I'm going from smallest to largest. Okay, so again, I'm going to draw a line through it just to make sure of the fact that I'm not considering it, I'm ignoring it from now on. Now I've got a 9 in that place value on the other 2 when I compare them. 9 and 9. And then this last location has a 9 down here, but it didn't have anything on top because the number on top is actually a 0. So even if you didn't write it in, you need to be thinking about the fact that there is a 0 in that location. So as I compare these now, the first one and the last one, which of those 2 is smaller? The first one. So this one is the, I'll call it the second smallest, which makes it the second number in my list of numbers. And then the last one would be the second largest, or you could write third smallest. I was going to write second largest as well. Second largest, which makes it the 3rd number in my list of numbers. Okay, so can I do it in a string across the top like the problem was given to me? I mean, I can, but you are so much more likely to make a mistake than if you line them up and can see them vertically. So that's my suggestion on that. Now, the answer actually, or the question actually asked us to write them in order, and I haven't actually done that yet. I've identified the order, but I haven't written it that way. So the answer itself is to write these in order from smallest to largest. So the first number is the number 1 one that I listed, which was 13, and I had a decimal point. And then I had 49183. You can put a comma if you'd want, or you can put a less than sign, because that is the smallest one in order. It doesn't matter to me which one you use. The second one was the 13. It was my second smallest, the first number listed. And the 4919. Okay. The third one is the last one that was listed. That was the 13, and then 49199. And then my largest value, which was the first one I actually identified, was the 13 in 492 thousandths. Is that okay? Excellent. All right, this is one of my fun questions that I like to ask because it works so nicely. And it actually came straight out of your book, so I didn't even make it up, which is even cooler, I think. What is the meaning of the word tithe? So let's just stop right there. So when you say tithe, actually, let's ask you a question a little bit. When you say tithe, what do you think of? Money given at church, something like that, right? Tithe. What is the meaning of the word tithe? It's what? 10% or 1/10. some of that language is all related to each other, right? And then our question is then how is that related to decimals? There should be a question mark at the end there. Okay, so then the meaning of the word tithe is the phrase 1/10, and that's how I'm going to write it just because we aren't working with percentages at the moment. It is 10%, you're right. But in terms of decimals and fractions, 1/10 is the language we hear used. 1/10. Now, if you look it up on, like in a dictionary or something like that, it may sound something like this. It'll say something like, or it might, 1/10 a part of something. Now, in evangelical Christian faith, we use it for our income, right? If you look back into Jewish history, they would have taken 1/10 of all kinds of things. Like you'll see a point in the Bible where Jesus talks to the Pharisees and he says, you tithe 1/10 of your spices, but you fail to do other things. So can you imagine going through your pantry and measuring out 1/10 of your oregano? I mean, like that's what he's kind of talking about. So it doesn't have to be money is my point. We use it in an evangelical way to talk about money, 1/10 of that. So in practice, what does that mean for us? That's true. I was thinking more in terms of what happens when we actually take 1/10 of an amount of something. So let's say, for instance, that you had you did some babysitting or maybe house sitting or something like that for someone and they gave you some money. How much money might they give you? $40. Okay. So in practice, if I earned $40, then 1/10 of 40 would be what? Right, it would be $4. So that's what we're actually looking at, is we're talking about something being 1/10 of something else. And of course there is the fractional that looks like this, 1/10 of the 40. Or you can talk about the decimal point, 0.1 of the 40, right? And they both, of course, will equal the $4. But both of those are related directly back to this idea of decimals. Also, just kind of to think in mind, that's why it doesn't make sense for somebody to say something like, I tithe 5%. Right? I mean, like the words just, I mean, you can say that you give 5%, but you can't really say tithe in that context, right? Or I tithe 15%. No, that word doesn't work there because tithe already has its own meaning. So be careful when you're thinking about that language.